Hi, everyone. Well, I'm gonna start the session here. I know we have a great session ahead of us, but thank you so much for joining the session. So whether it's your cell phone that connects you to the world or the device you use to attend this conference, our future is connected, and 5G is an essential ingredient to make the future a reality. All those connection devices and apps require an even greater emphasis on 5G cybersecurity. Hello, everyone. My name is Trenh, your in-app moderator, and welcome to the 5G cybersecurity breakout session. I'm a business banking relationship manager at Bank of America, and I'm excited to introduce Mr. Rob Tiffany. So Rob is the vice president and head of IoT strategy at Ericsson, where he drives strategies and execution at the intersection of 5G, edge computing, and Internet of Things. He joined Ericsson in 2018 from Enterprise IoT, where he was founder and CEO. There, he created edge computing system powered by digital twins that targeted enterprises and industrials. As CTO and global product manager at Hitachi, he received the Presidential Product of the Year award for designing the Lumada industrial IoT platform that landed in Gartner's leader quadrants. Spending most of his career at Microsoft, Rob was global technology lead for IoT, where he incubated the Azure IoT cloud platform and co-authored its reference architecture. Prior to Microsoft, Rob was co-founder of NetPerceptor, where he developed one of the industry's earliest mobile device management platform for smartphones. So in this session, Rob will share with us the latest effort to secure the Internet of Things from complexity and security threats as we move into the future. So as a reminder, at the bottom of the screen, you may type in your question anytime during the session. Q&A will be at the end of the presentation, and then if time runs out and we don't get to your question, we will connect with you at a later time. And lastly, there will be a session feedback form where you can add any additional questions after the presentation. We will reach out to you after the conference to connect. And so now, everyone, here is Mr. Rob Tiffany.
All right, thanks for the nice introduction, Dee. Let's dive in. We're just gonna take some time here. I'm gonna give you a deep dive on what 5G is. If we kind of dive into here, let's see here. Now it looks like there we go. Here's me. I'll do this really quick because I already got an intro from Dee. Currently working on an interesting little side project right now inside Ericsson called Thunderstruck, and it's basically applying Internet of Things and connectivity to agriculture, the agri-tech space. You can imagine putting sensors in farms and letting farmers know when they need to water their crops and things like that, and chemicals and stuff like that. I'm executive director at a Moab Foundation. That's a nonprofit where we're using IoT and digital twin technologies to help sustainability. If anyone's familiar with the United Nations Sustainable Development Goals, it applies to that kind of stuff. Elevator kids, we raised, during COVID, all of a sudden we had a lot of kids going to school at home, right? My wife's a teacher actually, and so she was having to do that. But we found out a lot of kids didn't have laptops or connectivity. And so we started this foundation and raised money to get laptops, Chromebooks, things like that for kids, and worked with T-Mobile to get them connectivity in their houses. I worked with some people that are here today at camps, from the Hitachi team when we built Lumada together. And so that was a fun experience. And as Dee said, I used to work at Microsoft. So let's go ahead and dive right in. Today, I'm just going to kind of walk through some just really high-level slides to tell you all the ingredients that are inside 5G, because you may not know all this stuff. It might be more information than you want to know about 5G, but it'll kind of round it out and let you know its capabilities. So when you think about maybe using it in your enterprise, I'm going to talk about hackers out there and the attacks that we're under all the time and kind of go into that a little bit. And then since I work in the Internet of Things space specifically, I'm going to kind of do a quick top 20 countdown of things you should be doing to secure your Internet of Things devices. So let's dive right in and start talking about 5G. There's your cell tower. If you look at those kind of rectangular box things up on top, that's what we make at Ericsson, where I work. We're one of the handful of companies that actually makes 5G technology in the world. And so that's kind of your typical cellular tower where you see that stuff come from. So I'm going to talk about, just kind of go through high level capabilities of 5G. As you can imagine, the first thing people think about is speed, right? I actually did, if you ever use the speed test app on your phone, you can see, depending on where you are, what your download megabit per second and upload speed is. I actually did this up in Snohomish, the actual town of Snohomish. I was sitting outside from a restaurant, and you can imagine getting 644 megabit down was insane. I know a lot of people pay a lot of money to have that kind of speed at their home internet, whether it's coming from a cable modem or something else or fiber. And so it's pretty amazing. And the upload speed is important too. We're all doing things like this, like Zoom and Teams and other WebEx. And so that upload needs to be going for you. It's possible theoretical peak speeds for 5G as we're currently rolling it out around the world, and there'll be new advances in 5G that are going to come out in the coming years. You'll see peak speeds of up to 20 gigabit per second down and 10 gigabit up. So pretty crazy stuff. So how does 5G work? Well, it's like a big layer cake. I know this will sound strange. It starts with fiber though, at the very bottom. Obviously electricity is at the bottom, but then there's fiber optic cable all over the world underneath the streets that you can't see it. And that's that high speed optical networking that creates the baseline to move data around the internet. When you get close to those cell towers, like the one I just showed you, there's things called base stations and all these other things. We use really fast Ethernet. A lot of you are probably familiar with Ethernet, working in, if you're in IT or stuff like that, and running cables. So we got 10 gigabit Ethernet, which is really fast. And so that's running in those cell towers. Then we have like these three kind of bandwidths. Cellular is all about spectrum. You may hear about governments having spectrum auctions where mobile operators like AT&T and Verizon and T-Mobile spend tens of billions of dollars to buy a slice of spectrum. Just think of it like your radio in your car, whatever the megahertz in your radio. So the high bands is called millimeter wave. We're talking above 20, 25 gigahertz, really high frequencies. They don't go very far, but they are super fast. Anywhere from a half mile. Some new technologies with new antennas are getting up to a mile. But it's super fast. So like if you've seen, like Verizon launched with millimeter wave initially in all the NFL stadiums. Of course, it was bad timing because COVID happened. We didn't realize we'd have nobody in stadiums. But that was to give people were getting like 1 gigabit speeds already with that kind of stuff. So that's amazing. Mid-band, it's kind of the Goldilocks, just right. They call it sub-6, so it could be like 2.5, 3.5, gigahertz frequencies. They go many miles and it's super fast. So like that speed test you saw me do in Snohomish, that was on mid-band frequency. So that was T-Mobile, and they acquired Sprint. Sprint had a lot of mid-band frequencies. And so it goes a heck of a lot faster, and it goes a few miles in range, kind of like your typical distance for wireless. And then there's low bands below 1 gigahertz. So it goes much farther. It's not as fast, and it has deeper in-building penetration. I love to describe these frequencies. I know this is all bizarro stuff. Just think of it like your home stereo and your speakers. You've got tweeters that are really high sounding and they're really directional. That's like millimeter wave. You've got mid-range, and then you've got your woofers, right? And subwoofers. And notice how you can put your subwoofer anywhere in the room and it doesn't matter. Think about the low band. So like T-Mobile had their 700 megahertz low band that goes up to 100 mile kind of diameter, not quite, but up to that. So that's kind of where we are. That's the layer cake. So latency, this is how quickly you can get to that full speed. It doesn't just happen instantly. It's how many milliseconds. With LTE and other technologies, it takes longer to kind of ramp up to that speed. With 5G, you get up to it in just usually single-digit milliseconds. It just depends. This allows us to do time-critical communications or real-time applications. You can imagine enterprise deals in factories or whatever, where you need that real-time stuff that you're usually using Ethernet for. Now you can look to 5G for this stuff. That whole end-to-end from one endpoint to maybe a server or something else, up to 5 times reduced latency speed times. To make it relatable, if you're a gamer and you play multiplayer games, you talk about ping times. What is the lag, right? when you're playing multiplayer games on 5G, your lag time goes dramatically far down. And then we see a lot of telehealth happening during COVID because we've all been remote. The latency is so small now that it is possible to start doing remote surgery, which sounds crazy, doesn't it? But it's pretty cool. Velocity is another capability you probably haven't thought of. So you ever think about like when you're in a moving car, or if you're in a bullet train, obviously not in a plane because we're not supposed to have it turned on, right? But how fast can a phone or something, an endpoint, move through space while still staying connected? So basically about 310 miles per hour now, your device can still stay connected and do its thing on 5G. So that's pretty cool. Location. I know you normally think about GPS when you think of location, but you can also, we've done things in the past like cell tower triangulation to figure out where you're at. Takeaway with 5G, it's within 3 feet just using new 5G cell tower. A lot of this is from government regulations, like for emergency service and first responders, finding you if you're lost or something like that. And so that capability had to be put in. Capacity is the one of my favorites. 1,000 times more capacity. What does that mean? It means the pipe just got a lot bigger. So you can imagine, like with normal 4G, if you're driving around one of those cell towers that I showed earlier, normally you might have 1,000 or 1,200 connected devices. Imagine now 1 million concurrently connected phones or IoT devices in a 1 kilometer radius around that cell tower. It's just amazing. So much more capacity to do more. So you think about smart city projects, or where we're going to have connected vehicles communicating with each other. We are now going to have that capacity to just have millions and millions of devices in a city, and buildings and lighting and freeways and cars and sewers and everything, all communicating without creating bottlenecks, which we would have had in the past. Network slicing is an interesting capability, and this also plays into security a bit. Network slicing, your mobile operator can literally slice off dedicated, isolated, segregated segments of connectivity to you, to a company, to a factory, to a farm, things like that, and give them their own quality of service, and they're secure. They're not shared with everybody else on the network, which is truly amazing. And it's also great for security. If you need to have, you don't want to be on the same network with everybody else on the cellular network. So those individual slices are really great way to secure things, especially if when you're thinking of connecting machines in a factory, you might want to use network slicing to give that dedicated there. Dynamic spectrum sharing. This is some geeky stuff. You may not realize it. I talked about spectrum before. Literally, all the mobile operators spend tens of billions of dollars to buy some kind of weird spectrum, like 700 megahertz or 3.5 gigahertz, and they spend so much money. You hear about these auctions. The last auction was like over $100 billion. So it's really expensive. So what this dynamic spectrum sharing allows to, and it's a technology from Ericsson actually, that lets mobile operators use existing spectrum for older, like 4G or 3G technologies, to have 5G right on top of it. So it allowed some of your mobile operators to get 5G out in the market faster than they would have otherwise. Energy usage is a huge thing. So if we talk about IoT devices, there's this technology called Narrowband Iot, which is part of the 5G spec. It's carried over from 4G. It's been advanced up to 10x longer battery life, because I spend a lot of time doing things in agriculture out on farms, and so those are totally battery operated, and so I don't have a plug to plug them into. So those devices need to last as long as possible on battery, up to 10 years in some cases. It just depends on the device usage and how much data it's sending. But really, they're sleeping most of the time. So it's really great stuff. Also, energy savings. If you think about each cell tower doing 5G, and I told you how it's supporting up to 1 million connected endpoints per tower, but it's using the same amount of electricity. It's giving you 100x or more speed, 1 million devices, 1,000x more capacity, but not using more electricity. So we're getting a lot more for the same amount of energy budget. And we're working to push that energy usage down on cell towers. Private 5G is something you may or may not have heard of. This CBRS thing, it sounds like Citizens Band Radio. But what it is, it's a program for the U.S. government where enterprises like yourselves, can work with the government to say, hey, you know what? I need some spectrum because I want to do private 5G in my factory, in a warehouse, on my campus, stuff like that. And I'm going to do that maybe instead of Wi-Fi or even instead of Ethernet in some cases. And so you can get that spectrum from the government at a low cost. They'll say, okay, we'll give you a 2-mile radius of spectrum in wherever you are. And then it's dedicated. And this gives you, and the roaming characteristics of 5G inside buildings is amazing. Also, a lot of times, a lot of factories and shop floors, people try to put Wi-Fi, but sometimes the heavy metal objects in there cause interference when things move around. 5G doesn't suffer as much as Wi-Fi does in that capability, and people and things can roam securely inside there. And that last thing there, I have a little SIM card that you put in phones. So if you're doing private 5G, you'll get these, they look like smoke detectors, and you put them in, maybe connected to Ethernet drops, just like you might do for Wi-Fi access points, except now it's cellular instead. And you're literally given a SIM card writer, and you create your own SIMs, and it writes the secure coding on each one of those SIMs, and you put them in your cell phones, your IoT devices that are all going to be on that private network, and the entire network is closed off to the rest of the world, and it's fully encrypted. The only way you can be on it is if you got a SIM from the SIM writer. So it's a great security story in itself. A few other geeky stuff around 5G security. Needless to say, we have got great encryption from end to end, from device endpoint over the network through the backhaul system, back into the back office and on. And so it's a great encrypted story. There used to be this notion a long time ago where devices could pretend they're a cell tower and they could capture your phone calls. Obviously, that can't happen anymore. Some folks are using, a lot of people use Wi-Fi. It's very popular. We all have it at home, and a lot of big companies have Wi-Fi everywhere, and they use this WPA, which is their security. The problem sometimes is you're hopping from Wi-Fi point to point, and you have to jump off the security and then jump in, dive into another thing before you get to your destination. So cellular is a lot more secure than Wi-Fi is. And then you're getting carrier grade availability. So you don't always think about network availability and data availability as part of security, but it is. And so carrier grade availability of the network and your data dramatically exceeds enterprise availability. Devices, literally, not only are they authenticating like with your backend systems with programs that you've built, but devices are having to mutually authenticate with the network itself, and there's encrypted signaling, a lot of geeky stuff there, just to make sure devices at every stage of the system are completely secure. So a lot of good stuff around security there. But of course, we have to be vigilant. We're getting attacked all the time, and so I'm going to just kind of go through here some of recent hackers' greatest hits, just to scare the heck out of you, right? You may or may not have heard of this Mirai botnet. So botnet is like software takes over devices, computers, and they start doing distributed denial of service attacks all over the internet. Mirai started in 2016. We thought we got rid of it, but it's still kind of lurking around there. But basically, that was all IoT devices using default passwords. The hackers got into them, and they took over. And not only did they take down most of the internet, they actually took down a small country too. So not good stuff. You may have seen a video on YouTube of how you remotely hacked a Jeep through its infotainment system and started changing the speed and steering and things like that. So that's kind of scary stuff there. This camera attack, this happened in the last year, early this year, actually. It affected Tesla, schools, hospitals, where they were taking control of cameras remotely. I think everyone's probably heard of what happened with SolarWinds last winter and early spring, attacks on government agencies, the Pentagon, Microsoft. That was a huge, massive attack. And, and again, these are from nation state, actors who are doing this. And so the SolarWinds thing is definitely one of the most devastating things we've seen in a long time. So much IP stolen, things like that. In the old days, you'd have to have a bunch of soldiers storming into buildings with guns, right, to do this kind of stuff. We probably heard about the Colonial Pipeline. They're literally, I know you always hear sometimes ads on the radio about the dark web, and you probably wonder what the heck is that? Well, it's a thing, and there's storage passwords sitting out there, and people grabbed that and they were able to take down the pipeline, and it impacted most of Southeast United States. So scary stuff that we have to take seriously. A lot of people don't think about security. They're thinking about, I have a job to do, I'm building technology to meet a goal, and security is kind of an afterthought. But it can be devastating. So this book really shook me to the core. And so I thought I would just throw it out there. This is how they tell me the world ends. I know that sounds kind of almost over the top, like link bait, right? But it is. This woman, Nicole Perroth, she's a reporter for the New York Times, and she wrote this book. And it was probably good to have a layperson describe the horrors that are really happening out in the world when it comes to cybersecurity, things you had no idea is going on, rather than some security expert, that's going to talk their own language. So I watched her do a fireside chat. I think it was with USC or Stanford, and it just shocking. She talks about, if you ever heard of Stuxnet, this was an attack that the United States did actually with Israel and Iran to shut down centrifuges that were developing, enriching uranium and stuff like that. This hits right to, everybody here in camps. You're doing manufacturing. You've got SCADA systems. You've got PLCs in factories. This was a worm that was created using what we call 0 days. A 0-day attack. It's like a vulnerability that no one knows about yet. It hasn't been patched. Normally you do Windows update would patch your PC. And so there's 0-day attacks that impacted Windows. They went through PLCs from Siemens, and they made these centrifuges go super fast, and they kind of went crazy and blew up and everything. And then it kind of leaked out of there too, and kind of got around the world. This is crazy. Also, 0 days. It's probably 0 days are being stockpiled like nuclear weapons are being stockpiled. And so in the old days, people would find a vulnerability, good hackers would find a vulnerability, and they would notify Microsoft or Apple or whoever, was making the software so that they could release a patch. Well, after a while, there started to become a black market for 0 days where they didn't notify. And so people literally started stockpiling 0-day vulnerabilities without telling the companies, so that they had a vector to attack these systems. And people are getting millions of dollars, tens of millions in many cases, for 0 days. The NSA, here in the US has the best hacking tools in the world, but guess what? They got leaked out onto the internet a couple of years ago. If you've noticed how hack attacks are skyrocketing in the last few years, it's because of this. Everybody on the internet now has the best hacking tools in the world, and it's pretty ugly like that. So when Russia got their hands on the NSA hacking tools, just to try out these tools to see how they worked, they literally just bombarded Ukraine like you wouldn't believe. Everything was shut down, every computer screen, everything, ATM machines, think about communications. They literally brought the whole country to a standstill. Interesting commentary in this book when they're talking to security experts in the Ukraine. We all think how cool it is to build highly connected smart cities and things like that. Their perspective changed so much after being attacked that they say things like smart cities are actually dumb cities, and dumb cities are smart cities, which is a completely different perspective from those of us trying to do digital transformation, or where we're on an industry 4.0 journey. They actually said, hey, luckily this didn't happen in the US, because the US is way more connected than we are. It could have been a lot worse. So really interesting stuff. So kind of what I want to leave you with here, you may have heard this term zero trust in the last year. What this means is, when it comes to security, in the past, people had this notion of, there's my castle, that's my company, my enterprise, and I've got a moat around it, a perimeter where I'm securing it. And, it's like my firewalls and segmented networks and things like that. If you make it through there, then you can do whatever you want, because we know that you're good, right? Well, zero trust says you're never good, and we never trust you ever. Now, I know that sounds really bad and scary, or like, how am I gonna get things done? But if you kind of go with me here, a person or types in usernames and passwords to get into a system, Internet of Things devices passes along identities and security tokens or certificates. The difference with zero trust is once you get through that outside barrier, it doesn't stop there. Everything has to stay encrypted the whole way through, data in motion as it's flying through the network, data at rest when it's on file systems, when it's in databases. But then when data needs to keep hopping to new locations, like maybe to perform analytics on that data or other things, it needs to be re-authenticated over and over again, because now we have zero trust. Most of the big hyperscale cloud providers have this notion of assumed breach, where they assume the bad guys are already inside AWS and Azure and GCP. And so they operate like that. And so zero trust is just not trusting anything and never giving you a free ride if you VPN'd into the company. So I highly encourage you to look it up. It's not a product. It's a bunch of principles. But I'm seeing a lot of security companies start to get on the bandwagon with zero trust. All right, now I'm going to do kind of a countdown or a count up. Since I live in the Internet of Things world, I'm going to give you my top 20 list of kind of things you should do on your IoT devices to get them secured. Some of these will sound really simple and easy, and you'll be like, I can't believe people aren't doing this, but they're not. And so we'll go through those, and then we'll have time here at the end for questions. So let's go do our countdown of the top 20. So number 1, I know this sounds so obvious. Change that default username and password on that IoT device. This is how the Mirai botnet and some of these other ones got started. Every device, PCs, servers, all kinds of things, they usually have some kind of default username and password that they come with. Well, those hackers have a list of the default usernames and passwords for all these devices. And so when they did their brute force attacks, that's what they used, and they had great success. They got tens of millions of devices completely hacked. So take the time and change that stuff when you're installing that IoT device. I know it seems obvious, but it's just not happening. Also, kind of in conjunction with that, that password needs to be strong and it needs to be unique. I know that sounds like a duh, but you'd be amazed how many companies out there will use the same password for everything because it's too hard for them to remember or have an encrypted list of usernames and passwords or secure or unique identities and passwords for devices. So they got to be different and they got to be really strong. It can't be 1, 2, 3, 4 and stuff like that. Secure boot, that's a little more esoteric. That's a technology. A lot of the technology is actually, just as an aside, the reason IoT devices are getting so much better and all these great capabilities is because of the smartphone revolution. That started way back, I got to be a part of that, all the way back in 2000. Microsoft had something called the Pocket PC, and then we had Windows Mobile, and then Windows Phone, and then iPhone came out and Android. But that revolution, there's so many sensors that kept getting put into these devices. And then as those devices were getting hacked, there was new capabilities. So this one thing called secure boot, it was a smartphone thing, and it had to do when your device is loading up the first time. And now they've added this capability to PCs and things like that. But basically what it means, if you're familiar, like booting up a computer and you know something called the BIOS, basic input output system to let your operating system talk to your hard drive and file system and work with the PC. This is a replacement for like that. There's this UEFI boot and stuff like that. So secure boot just means that boot sector is not tampered with. So you couldn't have a bad guy who's already in control before the operating system comes up. So look for devices that do secure boot. Here's another geeky thing you may never heard of: trusted platform module, TPM chips, or which is on a PC. Like if you've got a Windows PC, running on an Intel chip, laptop, or if you got a Mac, most of them have something called a trusted platform module in that. In fact, if you've watched the news recently here in the Puget Sound area with Microsoft launching Windows 11, one of the requirements to install Windows 11 is it has to have a TPM 2.0 chip built into it. This is Microsoft trying to really raise the bar on the level of security of computers. And so that's a secure element you can store secure credentials. It also helps things like BitLocker encrypt the hard drive. The reason I call it ARM and Trust Zone, it's similar. ARM devices, you normally think of your smartphones. All the smartphones are running on ARM chips. And of course, as you've probably been watching with what Apple's been doing lately, their new MacBooks are now running on ARM chips as well, that M1 stuff they've been talking about. So Trust Zone is just a TPM equivalent to put that trusted data in there and to help encrypt things. Don't hard code credentials. Again, another obvious sounding thing, but more times than not with these IoT devices, there's software written on the device that pulls together all the sensor information, temperature, humidity, whatever it happens to be, pulls it all together and packages it up to send it over the network, maybe to a cloud or a server or something like that for analytics. But more times than not, the identity, the trust packet, the password, the whatever it has to be, a security token, people keep hard coding that in code and assume that's going to be okay. It's not good. Just stop doing it. That needs to be separate. Now, obviously, having it separate on a text file on the device to read is probably doesn't sound great either, but it's still a step in the right direction. Hopefully the device has encrypted storage. The best scenario is have those credentials, that unique identity and that security token stored in the TPM chip or ARM Trust Zone is the best way to do it. Encrypted storage to secure data at rest when data is coming from a landing, right? So it's data on your IoT device. Hopefully that's encrypted. If you're using edge computing devices outside the network, having that encrypted at rest is good. Every place it lands, back to the zero trust. Every time data is landing somewhere, whether it's a file system in a database, in a message queue, whatever, that stuff needs to be encrypted every time when that data comes to rest. Outbound only connections. This one's a weird one. If you've got your IoT device, make sure that it initiates the connection to your server, to your cloud, your IoT system. Don't have your device listening for an incoming connection. In other words, don't build a web server on your device and listen, because that just opens up the attack surface. That's why web servers have to have firewalls and a lot of other things to secure them. So just don't go there. I know sometimes it doesn't make sense because you go, well, if I initiate an outbound only connection on my device, it means I can only send data, but I can't receive a command from the server to change its behavior. Well, that's not true. You can initiate the command and then things can be pushed down that existing connection from your server, or you can poll or things like that. So just never have devices listening. TLS. If you remember SSL, which is what people still call this, usually the secure sockets later, it's been called TLS for a long time, but it's an encrypted tunnel. It's what we're using right now, doing this transmission that we're doing here, this whole session. When you go to banks, every time you're in a web browser and you see the little lock on your browser, that means you, in the old days, had an SSL connection, and then these days it's called TLS. That means you're just an encrypted session. That's an encrypted tunnel between you, your browser, and maybe your bank or whatever you're doing. Everything needs to be encrypted with TLS all the time. So 1.3 is just the latest version. 1.0, 1.1 has already gotten hacked. So don't do anything older than 1.2. 1.3 is the newest and most secure. Do this from your IoT devices. Do it for every single connection you have. People used to shy away from that because encryption slows down things. It slows down your transmission because you're having to encrypt and decrypt on both sides of the packets. Anyway, we've fixed that. We've accelerated that. So encrypt everything. In fact, if you have a website, if you have websites that you're hosting out on the internet, if it doesn't have TLS, actually Google will mark you down and not give you as good a rating for people to search and find your company. And so make sure you have TLS. Your devices, the software on your devices, the firmware, which is really weird stuff, passwords, how you configure the devices, all that stuff needs to be remotely updatable. So what I mean by that is your device, your IoT device is secure at a moment in time. But as we move forward in time, vulnerabilities can be found. The hackers never sleep, right? Security is a journey. And so your device is only secure at a moment in time. So that device needs to be updatable, just like you update, your phones, your MacBooks, your PCs. They all update with security patches, sometimes every day, certainly every week, in addition to other things. Make sure your IoT devices are also updatable so that they can stay secure. Rotating security tokens. This is a weird one. If you think about, if you work for a company and you've got a company PC, it's very likely that they force you to change your password maybe once every few months, every quarter, something like that. So you're always having to change. And this is just to keep the hackers guessing. Because if you never change your passwords, it could be like the Colonial Pipeline folks, and the list of passwords that never change are on the dark web, and then that's how they get into the system and take out pipelines. So companies make you change passwords. Likewise, with IoT, make sure the IoT platform technology you're using supports the notion of having that device change its security token at some kind of frequency. So it's not always the same one, because it's just as bad as a person not changing their password. So get those things, that's a must. Firewalls. I know firewalls seem passe, but we still need them. You know, whether it's zero trust or anything, it's defense in depth. We're creating layers, right? One thing's not going to be good enough. So we always have layers. And so in addition to big firewalls from the big firewall companies so you can buy that run on networks, make sure your operating system has a firewall turned on. You know, I know Windows started putting a firewall into the operating system back in the Windows XP timeframe, because the internet was new for Windows and Windows was getting hacked to death. And so having a built-in firewall to lock down ports at the OS level was a critical thing. This is important if you're doing edge computing. You know, edge computing is a big thing these days in the IoT space and otherwise, and that's where you might have a hardened kind of compute device that's doing compute maybe outside the security of your network, and it's more vulnerable. And so make sure that it's got its own OS level past firewalls on there to help keep it safe. Device blacklisting. If you determine that a device has been hacked, you know, if it's seeing it, you're detecting anomalies, if it's sending too much data or sending big data or whatever it's doing that's not normal, you need to be able to blacklist that device. You need to be able to say, you know what, I'm going to disable this device. I'm not going to accept telemetry from it anymore because it's clearly been hacked. So that's a key capability that you need to have. Use a dedicated network infrastructure rather than sharing across a LAN or a Wi-Fi. What do I mean by that? I'll give you an example. So if you read that scary book that I showed you earlier, they'll talk about how a lot of US critical infrastructure has foreign state actors hacked inside that infrastructure already. Obviously, we're doing stuff about that. But what I mean by that is we were finding that, let's just say it's a power company with electrical lines, right? So electricity grid, that's a critical infrastructure, right? But we were finding that the people in the office building who work for the power company, you know, in their offices and cubicles, the LAN, the network that they're on, was somehow bled over and was shared with the critical networks that are operating the electricity grid or other utility kind of things. This is unacceptable, and we can't. All that stuff needs to be separated. We need to have firewalling. It needs to be completely different network segments that folks in the office can't see into that. Part of this is how the Stuxnet thing was able to happen in Iran, actually. Being able to hop through networks. In fact, when I talk about 5G and cellular, if those networks were cellular networks, they'd all be dedicated. And the Stuxnet worm would never have been able to find its way to its destination to hack the PLCs. So very important stuff to think about. I know some of this seems obvious if you're a network administrator or you're a security person. I know this sounds like basic stuff, but it keeps happening. And so we have to just keep kind of pounding it home. Limit IP address ranges. This is another thing, especially around IoT. Have a list, know the IP addresses or the range of IP addresses that your IoT devices should be coming from. So that if you start seeing IP addresses that look like they're coming from another country that may not be as friendly to us, that you won't let that data in. And so, because the problem is you could have a device that sends a correct identifier and a correct password or security token, but if it comes from a IP address that's clearly from a nation that doesn't like us too much, you know, you don't want to let it in. And a lot of times people don't think about this on IT. So, you know, you've probably been to websites though, where the website you logged in with your right credentials, maybe you were traveling around the world, and then the website goes, hey, I don't recognize where you're coming from. This is weird. And they might have you do some other steps of authentication. So make sure you do this with IoT devices. Just because it's called the Internet of Things doesn't mean you need to put them on the internet. There is definitely a battle going out on the internet right now, as you can imagine. It's a cyber war out there. And so there's no reason you have to do, there's no requirement to use the cloud, as you hear it from cloud people, to do the Internet of Things. You can absolutely do it privately. You know, there's no reason to go outside if it doesn't make sense. So you know, when I was at Hitachi with Rich Rogers, who's here today, and Aquila, who's here today, when we were building Lumada, the industrial IoT platform Lumada, we made sure that it was portable, because Hitachi makes things that don't need to be on the internet, like nuclear reactors. Probably not a good idea to connect that to the internet. That's a great way to lose your job, probably. And so when we built that technology, we make sure that it could run on premise at the reactor, or in a factory, or on a bullet train. So anyway, it's just, you know, don't make assumptions. A lot of times you'll hear marketing from companies telling you this is the only way it works. It's just marketing. It's not true. So don't do it if you don't need to. Multi-factor authentication. If you've ever had a deal where, you know, you're trying to log in, but then they say, hey, well, actually, I'm going to send a text message to you with a token, you know, or a unique number, and I need you to enter that in. It's something like that. And there's a few other ways they could do it through email and other things, just to prove that it's you and not someone who grabbed your credentials. So make sure that all your systems are using this multi-factor authentication. Actually, you should be doing that with everything these days, to be honest with you. Whitelisting sounds like the opposite of blacklisting. What that means, it's something that runs at the operating system level that just says, instead of saying, well, these are the things that can't run, or here's the list of things that can't come in, instead it says nothing works, and then here's the short list of things that can run or can execute in memory. And so especially if you think of edge gateways and things that are outside the network, you may want to have whitelisting to say, this web server, these processes are the only things that are allowed to run. Anything else, aka a worm, you know, some botnet that gets in there, if it somehow gets in and infects your device, if you're using whitelisting, which some operating systems support this capability, it can't even load into memory and start doing bad stuff. Basically, you know, the virus can't do its thing. And so whitelisting is an interesting way to approach this. I talked about zero trust earlier. Messages need to be authenticated and re-authenticated at every hop along the way. Don't assume that once you make it in through the moats and through the walls of your castle that you're safe. You know, assume that things are never safe. So keep doing zero trust, authenticate everywhere you go. This is a weird one, data volumes. So just think of file systems, hard drives on an operating system. There's this capability. This is again used in edge computing a lot in IoT. Write filtering. Basically, it just says this is what's allowed to be written to a hard drive, stuff like that. And that's another security capability. And last but not least, physical security. It's still a thing. People can still come in and grab stuff from you, right? Do a smash and grab and take your servers, take your hard drives, things like that. So even though we spend so much time talking about cybersecurity, physical security, your ability to get at something directly, we still need to protect those. And a lot of times, you know, a lot of good things are, you know, stored in data centers that are really secure, or clouds. And so that's all I've got. I want you to all stay safe. That's the goal of this. And I want you to go faster with 5G and build great solutions. So I know we got a few minutes here. Anybody's got any questions?
Well, Rob, thank you so much for that informative session there. I think I definitely learned a lot of things. Your countdown list was actually, you know, a lot of things like, hey, I haven't done that for my devices yet. So hopefully, you know, the attendees to the session there got something out from it. I feel free to type in your question on the chat function there. We'll go ahead and feed it through Rob. And but I do have one for you there, Rob. So what can a company do right now to kind of prepare the company for 5G, and is there ways for them to retrofit older devices to kind of meet that guideline for 5G?
Yeah, no, that's a great question. Clearly 5G, you'll probably need to work with a mobile operator that has 5G rolled out. And most of the big three have varying levels of 5G rolled out already. But yeah, the bigger thing is devices. The device has to have something called a cellular module on it to work with 5G or 4G. And no doubt about it, it's likely that there's way more 3G and 4G modules out there in the wild for you to use today than there are 5G. They're just slowly creeping up. Especially when I talk about that private 5G that you can use in your enterprise and on factory equipment, a lot of the capabilities, whether it's buying private gear from Ericsson or somebody else, a lot of them allow you to work with both LTE and 5G so that you can use what you've got today. And then when you're ready to upgrade to 5G and when those modules and other things are capable, they'll let you seamlessly upgrade. In fact, a lot of the hardware gear that Ericsson makes, going back, several years was software upgradable to work with 5G. So you didn't even have to replace hardware. But things like that will start rolling out. And then small devices, like when there's this notion of what's called massive IoT. And so when I talked about those devices that can maybe live up to 10 years on a battery, a lot of those are using either something called LTE-M, which is like kind of narrowband LTE, like 1 meg up and 1 meg down. That stuff carried over from 4G. And so if you have that stuff today, you can keep using it. And then this NB IoT, narrowband IoT, is a little bit different. It's even less bandwidth and can last even longer. That came over from the 4G days too. And so you can keep using those as well.
Okay. Great. One last question there for me. Sorry to take up your time there. So would you count that list on that? What's the if the attendees can take one thing away to bring back to your tech team or their technology team, what's the one thing? Say, hey, let's focus on this right now to make sure that you're properly secured, or you have the infrastructure in place to make sure that you're protecting your company on that.
Yeah, for IoT devices, clearly I'd love it if you do everything, but as it turns out, if you had just done one thing, like that giant Mirai botnet that took down most of the internet, if you had just changed the default username and password, that would have prevented the entire botnet from taking over most of the internet. And so just do the simple things, and I know there's nothing worse than people saying, I need you to write down a list of all these IDs and passwords. I know you're gonna, if you've got all these devices, I know you have to have a list somewhere. Have it be an encrypted list in a secure place, but just make that change, make that simple change, and that will take care of a lot of things right off the bat. Absolutely.
Awesome. Well, thank you so much, Rob, for the information. You all hear from Rob. That the simple thing here will definitely prevent a lot of hacking out there. I know for a fact that even my mother-in-law uses the default login ID and password just because simpler for her to go back and reference on it. But the little things that you can do today will definitely be able to help you protect your company and help you protect your employee and limit the interruption that you will get from your company there. So Rob, thank you so much for your information there. And we have about 10 seconds. So great timing there. Hope you all enjoy the session.
Thanks, everybody. This was a lot of fun.
Thank you guys. Great job.